Good morning, afternoon, evening, everyone. It's my great pleasure to introduce our speaker today, Zaruhi Hakobyan. Zaruhi is a postdoc at Université de Luxembourg. She is interested by dynamics in social media. It's not the first time I will be enjoying listening to her. So thank you very much, Zaruhi, for accepting the invitation, and the floor is yours. We have 1 hour in total.
Yeah,
So,
thank you. So you can ask question in the middle of presentation, right?
Sure. So
Yeah,
yes, it's
it's
a
like...
very friendly seminar, so people can jump anytime they want.
Okay, thank you. So today my talk is about how people create the content in social media and how it is spreading. This is a joint project with Zafer Kanik from Glasgow University. So, and yeah. And the most important question is like looking on this tweet which Elon Musk created in Twitter. Why I put this tweet? Because this is the second most largest reshared and liked tweet in a social media platform. First one was just about what famous singer died. And the second one is this tweet. And the main question is like why people create such tweets. And if we go to psychology literature, we see that people cares a lot about their social status and they would like to be recognized by their peers. And in this paper, what we try to do is trying to understand how this status-seeking behavior can help or affect your revealed opinion. So here is more important that you have a revealed opinion, which is better for you, but it's not like a belief that it's in your DNA and you couldn't change. So you have a revealed opinion which you can change from time to time, depends on your popularity incentive. So, and in this paper, what we try to do with status seeking, we called it like popularity incentives, that people would like to become popular in social media platforms, and they can adjust their revealed opinions to attract more attention, to get more likes from peers and etc. And here, what I'm going to show you today is connected with 2 parts. One, we will discuss social media platforms without a network, and then we will extend the model to a network where is a path dependence. So first case, you can think about like a complete network structure or something like Reddit or subreddit, where people can see everyone posts and they can react on it or not. And so the main question here is to try to understand how this rapidly transmission, higher connectivity in social media platforms and algorithms can influence on people content creation. So the main takeaway in this paper will be that this popularity incentives can create an endogenous echo chambers, in a sense that people can have revealed different opinions, but in the result they will create all similar contents. And but this popularity-driven adjustments can increase sometimes opinionation in social media. For example, if it's an earthquake case, people tweet more neutral posts, more like info sharing behavior compared to when it's political topic, when people are becoming more polarized. And because of this popularity incentives, we can see that it can increase or decrease opinionation in social media platforms. And later on, when I will show you an extension of a model, we can see how homophily influence on what content is created and how each agent's position can influence on what they would like to create or not. And when we will speak about from platform side, like engagement behavior, what they would like to see, whether like people will spend more times and get more likes, etc., and what they need to do. So we are beginning from a simple model. We say we have n agents, and you can think about complete graph where everyone follows each other and everyone has an in opinion on a given subject, and this opinion can be minus B, 0, or plus B. And later on, I will extend to a generalized case where there is a finite set of opinions. And but at the moment t equals 0, everyone simultaneously create a content, but content can be minus B, 0, or plus B, and content can be different when the revealed opinion in a beginning of period. And what we try to show here, but social media, we called it CN, can be different from revealed opinion in a society. So we can show that social media is different than society. And at this moment, what we are, in a simple case, we will call it transmission, but it's mostly like reaction of people on a given content. At the time t equal to 1, people begin to like a particular content or not. And we can see that in equilibrium, if they like, RJI is equal to 1, if J likes agent A's content, and it's equal to 0 otherwise. And in a result, we can see that people in equilibrium will like only content which is closer to their revealed opinion. Sorry. So before going to utility function, we would like to give a preview of it. So what we main concentrate in our utility function is these 3 main components. One is that as agent, you would like that your ideas will be spread. So for example, if you are anti-Trump, you would like to see in social media more anti-Trump posts, and this will give you additional utility. Either if it's spread, and either if you are not creating this content, you would like to see more content like this. Second is that you will get losses if there will be a content which is spread and which is different than your own revealed opinion. So for example, if you see more contents about Trump, positive contents about Trump, you can get this utility from it. And there is this final components which we call popularity incentive, that you would like that what content you create will become more visible in social media and get more likes. So going to utility functions. So as I explained before, this is omega p times Ri, how many likes you will get. So this is marginal utility from additional likes. This omega b times Rj bi minus Cj, this is like this utility, because you have this revealed opinion bi, and Cj is the content which is created, and if it's different than yours, you will get this utility from it. This component shows like how widely spread an idea which you like or hold. And this one we put as an assumption that people will have a self-expression. So people will wait their utilities, so they will have some expression, but they will create the content. And in assumption, we make that this is equal to 1 like from what you are creating, and you are happy that you had your additional investment in spreading an opinion like yours. So that's why we make this assumption that omega E is equal omega P plus omega S when you are creating content equal to your revealed opinion. So how mechanisms look like? First, as I say, people in a t equals 0 create a content, and t equal to 1, they begin to like it or share or etc. And what we can see that if we go back to our utility function, we can see that if you create content different than your own, and it's getting more likes when you get this utility. So it means that if you see a content different than yours, you would never add an additional like to it because you have this utility. And in equilibrium, it will be that people will like only content which is equal to were revealed opinions. And originally, before thinking about creating a content, people calculate like how much of such opinion is distributed in a society, and they calculate their utility function from creating different content and getting different RI in a spread of that content, and comparing with if you will create your own content, and when they will decide which content they would like to create. So this content depends on this distance between opinions and reach, like it depends on this bi minus cj. It depends also on these shared parameters omega p, omega s, and omega b. And in a network case, which I will show later, it can depend on homophily, diversity, connectedness, and if we have an influencer in a network or it's a periphery, what content they will create. And later on, we also will speak about path defendants, but this is a perfect information benchmark that everyone knows their own position and everyone knows reveal preferred opinion in society. So first of all, we would like to mention about what opinions we have. So B0, when people are creating a zero content, we call them non-opinionated agents, like people who don't have any biased opinion about the subject. And we will say that society B is more opinionated than society B prime if a number of B zeros in this society in Bn is less than number of zeros in B prime n. So if an unopinionated, non-opinionated agent is higher in B prime, when we will see more non-opinionated content, when we will see more non-opinionated people. And then in such way, we can also compare like social media C with social media C prime. And also we can compare later on social media C, like what contents we see in a social media compared to what opinions were in a society. So we can compare like if a society was more non-opinionated, what it will become, or if it was more opinionated, how it will change its behavior. So first of all, what we would like to say is like, what is popularity adjustment? Popularity adjustment is when there is one agent who create a content different where his own revealed preferred B. And this we will call popularity adjustment. And we define weakly more popularity adjustment and strictly more popularity adjustment, like in a traditional way. And what a popularity adjustment, what are main mechanisms which influence on popularity adjustment is the following, but we need to have different opinion groups in society, because if everyone has the same opinion, then it's like exogenous echo chamber, and there is no need to attract more likes or getting more share from others, so you will create your own content. And we need a sufficiently large popularity incentive that people would like to create an adjustive content. So in this three different opinion case, we divide society into high opinionated society, intermediate and low opinionated society. We write it like Gmax, Gmed, and Gmin. So as you can see, in high opinionated society, Gmin is equal to our non-opinionated agent sets. And there is Gmed, which can be plus or minus, and max also can be plus or minus. And intermediate, we have these non-opinionated guys are in a middle group. It's not very big. And low opinionated society, when there are bigger groups. So for example, you can think about Sweden, a low opinionated society, and US high opinionated society on a given topic. And as I said, at this moment, because we didn't describe the network, but if you would like to think in a network terms, you can think like a complete network, which can be illustrated like Reddit subgroups, where in Reddit there is a topic and people join to a particular topic and they begin to discuss a particular topic. So first one, what we try to show that how this popularity adjustment works, and we show that when society is low opinionated, when we have this non-opinionated groups is max group, or high opinionated society, we can see weekly more popularity adjustment content. And it's always, we can see more adjustment there compared to intermediate case when we have this unopinionated people in the middle. So why this can happen? Because, for example, in this case, if minimum would like to create to adjust their content, they will create a maximum group of content. And here also they can create a maximum group of content because their cost will be only B. But in intermediate case, we can see that minimum for creating a maximum group of content, which can be max or plus or minus, they need to take more cost, like 2B cost, compared to go to a MET. So we can see such cases when unopinionated people are not moving and minus or plus can move to this middle group, and that's why our society can become less opinionated, and in this case we will see less popularity adjustment because of number wise. So
Zaruhi, may I
yeah,
interrupt this?
yeah.
Because I'm not familiar with what is going on here. To get the results in proposition one, is there some optimization problems that are solved? And if you can say a word or two on them.
Yes, so we solve an optimization problem, like about which groups are moving, right? Like, for example, if we say that we have a Gmax equal to B0, right? In low opinionated society, we can solve a condition that when this one will move, right? Let's speak about popularity adjustment, one group moves. And usually it's minimum group who will adjust to get more likes, right? If, in the result, we will get that in low opinionated society and high opinionated society, people are more adjustive because cost is only B to go to, cost comes from utility function, right? So if you adjust your content and didn't create your own opinion, but create a different opinion, like if you are a 0 and you created a B, you take a 1B cost.
So, but I understand the description, but I'm not seeing what is the optimization problem that is solved. Everyone is optimizing his or her own utility, and you are getting something.
Yes. Yes.
Okay.
So if you are creating different opinion, then you will have this utility. And if you are creating your own opinion, you will get this utility, right?
So you
And we
are
can
comparing the two and checking which one is optimal.
Yeah.
Okay.
So if
Okay.
your popularity incentive is high, you can create to
Okay.
get more
Okay.
likes.
I got it. Thank you.
Yeah. And when we have this intermediate opinionated society, it can be that if they are very close to Gmed is very close to Gmax, right? Like, for example, we will say bigger group is 0.45, middle group is 0.4, and rest is minimum group, when it can be beneficial for intermediate group not to go to a higher group to attract more likes from a society because we are already very close to maximum group. And minimum group can go to GMED because they are very close, but cost-wise, going to GMed is more beneficial. So that's why we can see that in intermediate case is a big less popularity adjustive compared to high and lows opinionated society. Next one, what we try to do is showing that, so we will say that if a number of unopinionated people is bigger than these two thresholds, we can see always that social media is less opinionated than society. It can happen when we have this G0 is max, and everyone moves to G0, and this is a threshold for it. And then we can see that if our unopinionated group is bigger than this, we can see less opinionated content. It can be like in natural disaster case where many people either they have a particular revealed opinion how like government is handling a situation, they will create an unopinionated like info-based content that, oh, here we are helping, let's share some info-based help information. And we also can see that if this unopinionated group is very small, then we can see more polarized content in social media platforms. Like, for example, in political debates, that many people are polarized and you would like to take one side and you are creating more opinionated content than non-opinionated. So I will bring an example of this proposition one in a symmetric case. In this case, I will say that B plus is equal to B minus to eliminate this intermediate opinionated case. And we can say that here we can see high polarized society, right? Because a number of pluses and minuses are higher than unopinionated people. And here we can see low polarized society. In a number wise, if we would like to understand how this mechanism will look like, we can see the following. So in these two cases, I eliminate intermediate. So we have a new threshold here. And what we try to show like societal opinionation versus social media opinionation from 0 to n. Let's say that if number of the unopinionated person increases, so we will go like a linear line from 0 to n, and this is a total number of opinionated people, which will decrease from n till 0, right? If we have all people like unopinionated here. And if we put this adjustment thresholds, what we can see here, we can see that from 0 to G prime, everyone will create opinionated content, which is this green line. And in a social media, we can see only opinionated content. So zero unopinionated content. In the middle, there is no need to do a popularity adjustment. So people will create their own opinion. So that's why we see this going down. And if it's bigger than G double prime to N, then here plus and minuses begin to adjust to 0. And then we will see in social media more unopinionated content. So in this part, in the green part, we can see that this is like when 0 is mean group, unopinionated people are mean group and they adjust to a bigger group. Social media become more polarized. And here we can see that media become more non-polarized. And that's why this can be one of the reasons why social media platforms would like to decrease hate speech, etc., to get, or they are choosing a lighter topics, but people will adjust more and we will see more engagement in social media. And this other graph what tries to show number of popularity adjusted content. So here it's similar what we have, but here 0 opinion disappears, right? Here zeros adjusted their content, unopinionated people didn't adjust, and here plus and minus is adjusted. So equilibrium outcome with this threshold. When there is an adjustment, we can see how it looks like in content-wise. And this orange line, it shows that omega p is super high. Like let's say that if I increase omega p in a such way that everyone would like to adjust, here we can see from 0 to n over 3, all zeros will adjust, right? And from n over 3, all pluses and minuses will adjust. And we will see all adjustment. And non-adjustment in this case will be our x-axis. So there will be no adjustment at all. So this is one of illustration to see how like polarization will look like. And the other thing what we try to show is like how engagement will look like. Engagement in the term of likes. So from social media platform perspective. So here we compare two different cases when omega p is very low and omega p is very high. Not very high, but a bit higher than this one. And what here we can see, but this is a polarized case, right? In this case, we don't have any unopinionated agents. And still social media engagement level is not high compared to this one, compared to light topics, because here people are divided into two groups and likes per person is less, and that's why engagement will become less compared to this point that everyone has the same revealed opinion and we can see much more higher likes, right? And if there is no popularity adjustment and everyone create their own content, so this is this hyperbola which we see with a minimum n over 3. N over 3 is when we divide society into 3 equal groups. And what total engagement are showing. So if you create one post, all your group members who have that revealed or preferred opinion, they will like it. So that's why here we have n minus b0 divided by 2, it should be in a squared. And because we have plus and minus equal to each other, here is also times 2. That's why here we don't have 4 and we have only 2. And plus all likes that unopinionated people are getting. And here, changing omega p from 2 to 10. Omega p, you can also think like as a platform giving like money to attract more likes, etc., like people. So what we can see, but if omega p is very large, here we will have from G prime to G double prime with non-adjustment regime, right? And people wouldn't adjust in this regime. But if we increase omega p a bit more, we can see that this adjustment regime shrinks to n over 3, closer to n over 3, and more people are likely to adjust their content accordingly. So this is just trying to illustrate how like engagement level will look like. So for a given society, for example, if you will take somewhere here like a society, like which has a number of unopinionated people, you can see what will look like engagement with their true revealed preferences and with adjustment. And so people, what our social media platforms they can do, they can either manipulate with this omega p, trying to give them uh, additional benefits, but they will attract more likes to increase engagement in social media platforms, likes and reshare. Or they can also influence from our equation, depends on this B level, right? Thinking about what topics to choose, because here we can see that if topics are very, on opinion, very low, we will get again more engagement in social media because switching will become much more easier between groups. And that's why we try to discuss with two different societies like Sweden and US, and what we will say that if we have different topics like B prime and B double prime, and this B prime is less than B double prime. And we speak about high opinionated society where people are, where with unopinionated people are in a minimum group. So what will happen in B prime, they can switch and B prime wouldn't switch. And we can see that with high opinionated society, with B prime topic, either it's a less topic, it can become more opinionated than B double prime. Like for example, in US, people can easily say that they didn't like this food or etc. compared to like low opinionated society where like food related or lifestyle related topics wouldn't be so much big issue to say I like it or I hate it. They usually didn't express very much their opinion. And here we can see a similar case when we have low opinionated society and when people, opinionated people are easily switching among these topics. So we can see that B prime becomes less opinionated when B double prime. So which means that on they can become more polarized in politics, religion, etc., but they would be less opinionated in food or lifestyle. So now I'm going back to a model and I will redefine it a bit. So I will say that our N agents now they are connected through a directed and unweighted network structure. And what here is important is that there is now a transmission path. So for example, if I create a content and George like it, so my friends will see, all my friends will see what content I created, and some of them will like and some of them would not react. And if they reacted, then their friends can see a content and then they can react on it. And if some of them react on it, then their friends will see. And this is a finite number, right? So what this means, like in a Twitter, when you are following somebody and you will like his content, he will get your like and all his friends can see that he liked your content, and if they will like it, like will come to you and you will get additional likes, etc. So this popularity virality incentives is written like in real world in Twitter network structure when your friends of friends can see what content they liked and they can also react on a particular content. So, and here what we try to speak now, we have this path dependency, and we would like to speak about core periphery network structure. And here we distinguish three different types. First one we call periphery homophilic. Why? Because all peripheries has the same opinion as their core agent, and there is a link among core agents. In some literature, we called these like such network structure like um, galaxies or etc. So when core agents are connected among them and we have these peripheries, everyone has their own type, we call periphery homophilic network. And then what we try to do, we try to extract like from each periphery type the 2E and distribute it with other people. So that's why here we call the less periphery homophilic, because we distract 2E people from plus and give it to this E core, unopinionated core 0. We gave him an E from pluses and we gave another E for minus cores. And here we have non-periphery homophilic when they have 0, their own type of opinion holder people in periphery. And that's why we called it like that. And what here we can see that depends on this minus B0 and plus B, we can see that this periphery homophilic is minimally popularity adjusted because each core is followed by their own periphery. And in path dependence, as periphery content which they create couldn't be seen by anyone. So they will create their reveal opinion. So periphery will create, and in this core periphery network case, it's only core agents who can adjust their behavior. And we can see that this one is minimally popularity adjusted compared to this non-periphery one. And in non-periphery homophilic network is maximally popularity adjusted, because here if plus core will create his own content, he will get a zero like. He will have only his self-expression, omega p plus omega s. But if he adjusts and create a zero, then he will have his p0/2 plus E0 number of core agents from here, right? And in that case, he will distinguish if it's better off to create an adjustive content. And here we can see more that social media network will become less opinionated compared to periphery homophilic one. Next, what we try to do is the following. So next, we try to understand how this different E can be demonstrate opinionation in society. And we can see that if E prime is more periphery homophilic than E double prime, which means that here in E prime you have more peripheries with your own opinion type, then we can see that social media in E prime is weakly more opinionated. People will create more their own revealed opinion compared to E double prime, right? And in less periphery homophilic, as I explained before, there is more popularity adjustment towards to zero, and zero is randomly switching to plus or minus, but number of switches is more becoming like unopinionated. They will create unopinionated info content, and then we can see what social media will become less opinionated. And from this periphery homophilic network structure, we can also derive a total engagement level to see how much likes they will get. And as you can see here is a point where we have periphery homophilic network, and in core periphery network structures, this is a maximum engagement level that you can get, because everyone will like course content from their own type, and because of homophily, the fixed group size is equal. So that's why this periphery homophilic network gives you maximal engagement level. And here, what is important, we can see that. So here we increase E from 0 to with p/2, right, to non-periphery homophilic network structure. And here what we can see is the following, that total engagement is weakly increasing in omega p. So we can see that here engagement level is much more higher compared to here. But in other case, what we can see is the following, that let's say that we have two influencers in social media. One has more periphery homophilic network structure compared to the second one. So here what we can see, that the popularity adjustment, if you will give a first one incentive, like you will give a money-wise incentive to this core agent to create adjustive content, you need to give also this more diverse influencers omega p, because for this more diverse influencers, you need much less omega p that he will create an adjustive content. And in that case, you will increase your engagement level much more compared to if you are giving more periphery homophilic core agents omega p. So, and now to go to a more general case, we will say that each agent has this opinion, but now it's from minus b to plus b. They have one opinion in this distribution, and they can create a content from minus b to plus b. And here what we can say is the following. So if you take any network structure and begin to increase the diversity, then you can see more popularity adjustive content because of with different opinion groups, and people will become more friendly with different opinion groups, and then they will have more popularity adjustment. And it also depends on density of connection, as we saw in complete network structure or in the first model, which I show, and I say there is no network there. Engagement, total engagement is much more higher compared to core periphery network structure because of this popularity adjustment. And we need to have sufficiently large popularity incentives. I bring some examples uh, about omega p equal to 2 and omega p equal to 10, but we will see difference. So as we say, there is no adjustment if we give an exogenous echo chamber. So no one would like to adjust their content because they will get additional cost and not any likes. The next, what we try to show is the following. So we say that let's have agent I, who has a higher diffusion centrality than agent J. I demonstrate it here, but diffusion centrality in more diverse diffusion centrality. So for example, you can think that agent I and agent J hold the same opinion, but each content which agent I will create because of his subnetwork, it will spread much more compared to agent J content, except on opinion BI, which they both hold, because it will pass through all paths. Everyone will like it. They will get a similar number of likes. So, and so what we say that agent I has more diverse diffusion centrality than agent J, and if they hold the same opinion, which
Zaruhi, you are muted.
yeah, I guess I lost on internet. I'm back. So what I was saying here is that whenever agent I creates his own opinion, agent J will create the same opinion, and there will be a case when I will adjust his content and J wouldn't adjust his content. And here what we can see is that if agent I has higher diffusion centrality compared to agent J, then he is more popularity driven. This you can think about recently that Trump says that he would like to invite to a White House like more influencers, no such journalists from CNS or other like BBC or other portals. It can be because of influencers are more popularity driven and they can create a content which can widely be spread, and in our channel can be fact checked, but no one doing fact check for them compared to a journalist. So, but here what we try to show that if we just make a snapshot of network and one has more higher diversity diffusion centrality compared to other, he will always create more adjustive content. And the other thing what we try to show, we say that let's have a open. Let's say that there is in society there is this B star, which this is an opinion, and GB star is a number of people who have such opinion. And GC star is a number of agents who create this content B star. And before we were comparing different people having a different opinion on how widely it will spread. So we were comparing among people. Here we will compare among one person creating different content. What will happen if he will create B double star, or when he will create B star. So let's say that we will have an agent who will create B double star, and this has higher diffusion centrality, which means it will spread much more compared to B star. And in this case, what we will get that if we take these two opinions, no matter that B star is more widely spread in a society, we can see that B star in some cases can be much more created in social media. And why this can happen? This can happen in several ways. One can be that it's easy to adjust to B star, so it's not very much strong opinion, or it's not very extreme. And sometimes B star can be more extreme opinion. That's why people wouldn't like to create very extreme opinion, or it depends on a network position of holding such an opinion. And in this proposition, we try to show that sometimes it can be unpopular opinion, but because of a central position of a person holding that opinion, it will become more widely spread. And for this one, we made an example look like in a star network. So in star network, what we did, we give this core agent unpopular opinion. U means unpopular, and P means popular. And what we can say here, but there are connected peripheries and just peripheries. What is different between connected peripheries and just peripheries is the following, that core is following connected peripheries, and connected peripheries follows cores back. And just peripheries were follow core and didn't get any core following them. And what we can see here, that for example, you can think like a musician who got a central position, but he would like to say something about political issues, to discuss some political issues, and his opinion is minority in society. But because of this other connected periphery, if they create their own content, so these ones will always create the same content as core because they have the same content opinion. And this one has different opinion, right? But for if they create their own content, they will get only their self-expression, like that they spread their own opinion. But if they create the content which core would like to see, then core will like it, right? And when if this group size is bigger than this size, we can see that this unpopular opinion of core agent, like this musician, can become more spread in social media platforms because of this connected periphery would like to move to it, right? And now, before comparing our model to related literature, so this is adding a new opinion dynamics and learning models. So what is important here to understand, maybe because the first thing which is coming to a mind of people is about conformity model, where people try to conform their action to others. And in this model, what I show today, there is no, it's not a conformity model because, for example, if we distribute this minus b, 0, and plus b, right? So in conformity models, for example, if both of them will create a minus b over 2, like zeros create minus b over 2 and minuses will create a minus b over 2, then they are better off because they converge to a similar opinion. In our case, because of the second effect of getting likes, if they in a time period equal to 1, no one will like such a content because it will add their cost. So which means that there is no such action which we can converge to in a middle and create some conformity model behavior. So it can happen only in these cases where I fix plus and minus equally, and I was seeing a zeros behavior, and it was randomly going to minus and plus. But in general, our model is adding in a literature that does not look like a conformity model, and it shows how people change their opinion in social media platforms, and how polarization is different in social media platforms and in reality, because there are work like empirical works which were showing that don't blame social media to see more polarization, because they are not affecting very much uh, on on societal polarization, because they measure these differences between social media and society polarization. So this is one of the models which we try to show how this can happen and how like endogenous echo chambers can be created. Now I will go to conclusions. So in this paper, what we try to show is like how network position matters, how endogenously echo chambers can create it, and there are this can be empirically tested, or currently we are thinking to run an experiment to understand how people weight this omega P, omega S, and omega B, how important is it for them. And so this is an alternative explanation of creating echo chambers and subject-specific content in social media platforms. Thank you a lot.